Once again, ladies and gentlemen, we'd like to welcome you to today's MSDN webcast. And as a reminder, you can find this recording as well as hundreds of hours of other great content at www.microsoft.com/webcast. Today we'll be covering extended SQL Server integration services through custom tasks. Joining us today will be Danny Del Rio and Jesus Rodriguez, both with the 2Connect Incorporated. So without further delay, Danny, you now have the floor.
Thank you, Ryan. Good day, everyone. My name is Danny Del Rio, and I am a Solutions Architect for 2Connect. I welcome you today to this webcast. We're going to be talking about extending SQL Server integration services using custom tasks. Joining me today is our Chief Software Architect, Jesus Rodriguez. Jesus?
Good morning, everyone. My name is Jesus Rodriguez. I'm Chief Architect with 2Connect, also a BizTalk Server MVP. During the last 2 years, I have been working pretty close with Microsoft team, participating in design review for upcoming technologies like WCF, .f, Link, BizTalk Server R2. During these presentations, I'll be pretty much driving the demos. We have a lot of demos, simple demos, complex demos, and hope that you enjoy it.
Thank you, Jesus. I want to take a moment real quick to extend an apology on behalf of our president, Javier Mariscar, who could not attend. He sends his deep apologies for not being able to make here, so I really appreciate that. And let's go into the session prerequisites here. Our session today talked a lot about SSIS, so a good understanding of using SSIS to build packages is highly desirable. Also, we're going to be building some .NET components using Visual Studio and so on. So some familiarity with those tools and technologies would definitely come in handy. Going over our agenda, we'll start by introducing different types of extension objects offered by the SSIS object model. One of those objects is a custom task, and we'll give an overview of how to build and deploy a custom task. Following that, Jesus is going to show a demo of building and deploying a simple custom task so that you have a better understanding of how the different classes and attributes relate to each other. After the demo, we'll talk about some of the applications of the custom task. In particular, Jesus will talk about implementing conversations with SQL Service Broker as a custom task, followed by a demo. Another extension object is the data flow component, and we will give an overview of that, followed by a demo creating a simple data flow component. And after that, we'll go into some applications, data flow component, and we'll show an integration example with Salesforce.com using a data flow component with SSIS. A little bit about us. 2Connect is based out of Coral Gables, Florida. We are a Microsoft Gold certified partner. Been in the job a little over 12 years, doing mostly integration projects, Fortune 500 companies. We just recently opened a few offices in Bangalore, Australia. And our core business is oriented towards integration services using technologies such as BizTalk Server, SharePoint, SSIS, and mainly a lot of work with web services. In March of this year, we debuted our AdapterWorks product line, which offers off-the-shelf integration products like BizTalk adapters and SSIS components that you may use. So let's go right into the extension objects. SSIS object model provides various objects that you can use to extend the functionality offered by the built-in ones. These can be classified in three categories, mainly general, control flow, and data flow. We're going to be focusing today on the last two, control flow and data flow, which are the ones you're most likely to use. Out of the box, SSIS will provide some scripting tasks that you can use to add simple code snippets to provide custom functionality to your package. Now, the other option that the SSIS provides is building your own tasks from scratch by deriving from what's called an integration services object model, which is basically .NET code. So what are the benefits of building your own task versus adding small code snippets on the script task? Well, the main one is reusability, and it's the main reason why we would build a custom task. I mean, it can be used in any package throughout your organization. You can make a change to the code without having to redeploy your SSID package, since they are compiled and deployed separate from the main package. Since you are using Visual Studio to build your package, you can take advantage of all the coding flexibility that the .NET Framework offers. Another great reason is maintainability. I mean, if you use the same code snippet in various places in your package and let it decide to change it, then it becomes a maintenance issue to try to keep all your snippets identical. So it's a very good use for the custom task. So the SSIS model, provides some classes and interface that you would use when building your custom task. They can be found in the Microsoft SQL Server Managed DTS DLL, so you will need to reference it in your project. The main class that you will need to inherit from is a task class. We will talk about that class in the next two slides, I guess. There is a single attribute which is required, which is the DTS task attribute, and its main job is to describe the task to the SSIS designer. The interfaces are optional. One of them will provide the user interface that will show up in the designer, and the other one will help in persisting the settings of the task. Okay, so the task class. The task class is the main class that you will need to inherit from to build your task. It exposes three methods that you can override depending on your use. The initialize task method initializes properties within the task. This is the first method that the runtime calls. If your task will fire any custom events, then this is where you would define them. The execute method contains the code that processes when the task runs. And the last one, the validation method, is to kind of verify the correctness of the task properties and settings without actually running through the task. Task codes. Well, this class is really like for your information. You normally don't need to worry about it since the runtime will create it automatically for each task. But it basically serves as a container or kind of like a proxy to communicate with the runtime for your task. It exposes some services that you can use, like recent events, logins, and so forth. But the basic idea is that the task codes lets you focus on implementing the logic and functionality of the task, instead of requiring you that the common task functionality be recreated for each task and so on. So it takes care of all those things for you. The DTS task as a required attribute is mainly used by the SSIS designer. It uses the properties that you define here to locate the assembly in the GAC. So after the assembly has been located, it uses the other properties to load the icon, name, description, and so forth of the task. The IDTS task UI is an interface that you will implement to expose a user interface to your task. Now, this is an optional implementation. If you don't wish to expose a UI to your package, then you don't need to implement this class. It only calls two methods, the initialize and getView. GetView basically returns a WinForm that you created previously and you have deployed with your package. This one, the IDTS component persist, basically it's another optional interface. These methods are called by the runtime to load and save your settings for the task. In the demo, Jesus will show a little bit more details on how to use this. So once we created our task, how do we deploy it and integrate it into a site designer? Well, basically you copy it into the C-program files, Microsoft SQL Server /90/DTS task folder. You drop it in there, then you add it to your GAC. After that, you just go to your SQL Server Integration Services Designer Studio, and you right-click on your task pane, and you select Add New Item, Add New Task, and you just browse for it. It should appear right in there, and then it will be available for you to use during your package creation. And debugging is just the same way like you're debugging standard code. So if you're already familiar using Visual Studio to debug code that you created, it acts like the same way. You basically set some breakpoints in the source code, attach it to the process that's hosting the task, and then run the project. And they should be picking right up. So without delay, let's just go right into that demo, Jesus.
So let's explore a little bit how to build a custom task actually using Visual Studio.net. I'd like first to summarize a little bit what Danny was explaining. When you create a custom task, you have two main behaviors or flavors that you need to create, the design time and the runtime. The design times are the method that the designer will call while you are building your package inside Visual Studio. The runtimes are the methods that the DTS engine through the task host will call at runtime. So basically for every custom task that you build, you need to provide those two flavors. A third flavor will be the user interface that we actually also are going to be looking at as part of this demo. One thing to clarify probably is that custom tasks are part of the control flow, not of the data flow. For those of you that are familiar with SSIS, SSIS provides these two main interfaces, the control flow and the data flow. The data flow is more similar to the old DTS. It's the one intended to do heavy data transformation between components. And you can look at the control flow like a way to orchestrate those data flows. So in the control flow, you have tasks like send email, send message to MSNQ, service broker, file. Those kind of tasks that can be combined with your actual data flow component that transfer data from Oracle to SQL Server in order to provide a set of business process logic and data transformation logic inside your package. So the custom task that I'm going to be showing as part of this demo is a very complex task that actually adds two numbers. After 15 years of evolution in ETL technologies, every time that we need to choose a demo, we still choose the add two numbers demo because it's very illustrative from the purpose of the show how to build a custom task. So the first thing that you should be aware of is this attribute declaration right here that declares the signature of your custom task. The DTS task attribute contains values like display name, that is the name that your task is going to show on the toolbox once that is added, the description, and the user interface that we're going to be exploring later. So this custom task expects two variable names, integer variables. It will take those values, add it, and store the result in a third variable. Like I said before, you have two main behaviors that you need to implement. The design time behavior that in this case is represented by the validate method. That is a method that the designer will call at design time, and actually at runtime is called again just before the execute method in order to validate that the actual configuration of the task is okay. So in the validate method, you put all the logic to validate that the properties of the task are correct. And in this case, we put a custom validation rule based on the values. If one value is greater than 1,000 and the other is lower than 10, I'm not adding two numbers. So it's just for the purpose to illustrate what kind of validations you can add. At runtime, the engine is going to call the execute method. That in this case is just adding two numbers and storing the result in a third variable. So other components of the data flow can actually use that result and do further operations with it. So those two are pretty straightforward. An important part of building custom tasks is how to save the state of the custom task. If I fill 3 properties and I close my designer, I want that when I open my designer again, those properties are actually there. So Danny was explaining the IDTS component persist interface. That is the interface that you need to implement in order to customize the way that your task is going to be serialized to the XML language that the DTS package implement. And this is a huge difference between SSIS and the old DTS. SSIS is a complete declarative platform. SSIS packages are represented in XML, so you can look at it, you can edit it if you want. And when you build custom tasks, you can customize how your task is going to be represented inside of that XML. You can think in IDTS component persist as the equivalent to XML serializable in the .NET framework. It's the interface that you implement to actually customize your serialization. And when you combine those two, it's amazing the kind of functionality that you can achieve. If you have a task that actually has a property that is a complex object, you can use XML serializer to get the XML representation of that custom object and embed that representation in the SSIS XML. So you have a lot of choices and opportunities that you can play around in order to customize your serialization. The base 2 methods of that interface are save to XML and load XML. The save to XML method is being called by the designer. Once that you save the task, you close Visual Studio. So the designer is going to call that method, and inside that you have to provide the XML representation of your task. In this case, I choose to represent my 3 variables as attributes in my DTS and my SSIS package representation. Once that the package is loaded, again, the engine is going to query for the IDTS component persist interface and then call load from XML. And in load from XML is where you take the actual XML node that you previously populate using save from XML and manipulate that node to populate your state. I would like to take a look to this package that we have right here. It's kind of cryptic, but I'll try to find my task. Well, it's actually better if we explore the package from the designer. Sorry. So this is a custom package that we're going to use that, as I previously explained, use the add to number task. And when you double click the add to number, you have that user interface coming up. That is a custom Windows form. As Danny explained, you can build any type of user interface that you want. Using this section on the DTS task attribute, you actually bind your DTS task with a user interface, pointing the DTS task to the assembly that actually implement the user interface. And the user interface is just a class that implements the IDTS task UI. And inside the IDTS task UI, you should implement this method, getView, that what it's doing in this case is loading the form for you. So using that combination of IDTS task UI and Windows form or WPF form, you can almost achieve any kind of custom UI user experience that you want to give to your custom task. So what I was trying to show previously is the XML representation of my task inside the DTS package is like this. in my save XML, I chose to serialize the custom task as properties as an attribute inside an element. So when you click Save, this particular node that is being highlighted is going to be populated inside your DTS package. I'm going to run this complex package that is just adding two numbers from the variables, and then a script task that actually shows a message box with the result of the mathematical operation. So you see, it's a very complex SSIS package to achieve a heavy data transformation operation that actually adds two numbers. But would actually give you the idea how to build custom tasks that you can embed in your data flow. During this presentation, we're going to explore actually very complex custom tasks that you can use to achieve real business goals. So I'd like now to go back to the presentation and keep exploring the different options that we have when we create custom tasks. So the next example that I'm going to be showing is an actual real custom task that uses Service Broker. Even though when this presentation is not about Service Broker, I want to take 5 minutes to explore Service Broker concepts together with the universal data model of SQL Server Analysis Services and SSIS itself. You can say that Service Broker is one of the most innovative technologies that come as part of SQL Server 05. And I'm going to try to summarize this in 5 minutes, so you're about to hear the shortest Service Broker presentation in the world. So Service Broker is, I like to say, that is a technology that allows you to build reliable, queue-based, service-oriented database applications. And let's break that definition down on those concepts. Queue-based. Queue-based, for years, people have been building queue technologies inside a database. Every time that you have an application that needs to read data from a database, and you have another application that is reporting against that database, is a common approach to create a separate set of tables from one application and for the other. So that's a queue technology right there. You don't call it like that, but that's just a queue technology. You're creating a set of tables that allows you to put data in and pull data out from your applications. The database vendors are going on a step further and actually creating queue technologies that ship with the product, and the classic example of this is Oracle Stream or Oracle Advanced Queuing, and now Service Broker. So at the first level, Service Broker allows you to send data to queues and to pull data out from queues. And queues are first-class citizens in Service Broker 05. So in the same way that you can create a table, you can create a view, you can now create a queue. What that allows you to do is using T-SQL code or .NET interface or other sort of interface, send binary or XML message to the queue and have other applications that actually read the message from there. So until there, that doesn't sound much different than what MSNQ or MQ Series or JMS-based technologies provide. Probably the main difference is that it's on the database, but Service Broker is much more than that. Service Broker allows you to do reliable messaging. So once that you send a message to the database, Service Broker makes sure that it gets there. It allows you to do transactional messaging for the Those of you that are familiar with web service technologies, with queue-based technologies, you should know that transactional messaging is the hardest type of messaging to achieve. To create message flow that actually are enclosing a transaction across the internet, that requires a high skill level of different technologies. So SQL Server Service Broker provide that sort of transactionality across conversations. I'm going to explore conversations right now. In the same way that MSNQ or MQ series technologies are point-to-point messaging, so you send a message, and that's your communication entity right there. Service Broker provide this concept of conversations. So conversation happens between services. You never send a message to a queue, you send a message to a service. And a service is associated with a queue. So services are the endpoint representation of Service Broker, and this will be the whole definition of service orientation comes here. You can create services, you can associate it with a queue, and then you can implement contracts. And a contract expresses the message that a service can receive and the messages that a service can send. So the communication between services happens using conversations. Service, we have service 1 and service 2, and service 1 can send 2 messages, and service 2 can send other 2 messages, and that's a contract right there. And conversations is just an abstract concept. The actual primary concept is called dialogues and monologues. Dialogues are point-to-point conversation between 2 services, and monologues are publicly subscribed conversations from one to many. Monologues was originally designed as part of SQL Server 5, but it never made it to a product. We in TwoConnect, working with the Service Broker team, create a monologue implementation that actually we announced it in Tech at 06 this year, and the Service Broker team announced it in Tech Ready, Microsoft Tech Ready this year. So it's available if you want to test it. So even though when Service Broker and SSIS ship as part of the same product line, there is no communication between those, just a T-SQL code. SSIS provides tasks for communicating with MSNQ, but it doesn't provide out-of-the-box tasks to create it to communicate with Service Broker. So what we did is to create a Service Broker custom task for SSIS that allows you to build applications that combine the ETL features of SSIS and the messaging feature of Service Broker. So it implements two-way communication with Service Broker services. So you can send a message to a Service Broker services and receive a message from a queue. And it implements all the classical patterns that you have with Service Broker. So begin conversation, send message, receive messages, end conversation. It's completely based on the Service Broker security architecture. So it's based on certificates, asymmetric key infrastructure, and the custom task is built on top of the SSIS task framework. So what we're going to do next is to go right into this demo that actually shows how to use SQL Server Service Broker with SSIS. So what we are going to illustrate is a communication between two SSIS packages that happens using Service Broker. I hope that my resolution is okay for this demo. So we have a target SSIS package that is expecting a message from a Service Broker queue, and this is how the Service Broker custom task interface looks like. You can receive a message, send a message, begin a conversation, and end a conversation. And based on the option that you select here, you will have a complete set of options in the second tab. So combining those four behaviors, you can implement basically any message exchange pattern that you want. You can do a request, multi-response, sending a message and receiving 20, a multi-request response, a request response, a one-way, whatever you want to do. So this SSIS package is receiving a message, then it's executing a simple data flow that gets the XML message based on a rule. Is going to route the U.S. citizens to one table and the non-U.S. citizens to another table. Then is sending a response message back, like an acknowledgement, and is ending the conversation. The initiator side is initiating the conversation, sending the first message, waiting for the second message to come back, and then ending the conversation. So if this demo actually worked, you will be able to see a real-time service broker conversation in a graphic manner using SSIS. So I'm going to start my target package. And as you can see, it's sit there just waiting for a message. Now when I execute my initiator package, you should be able to see the flow between the two. So I'm sorry, I gotta minimize this. So as you can see, once that the initiator package sends a message, this package gets activated and receives the message, then the data flow got executed. Then the initiator package kept waiting for the second message to come back. The target package sent the second message, and then both end the conversation. So that was an example of a real-time service broker conversation using the SSIS custom task. So I'd like to go back to the presentation.
Okay, and thanks, Jesus. Yeah, that was a pretty complex one. All right, that was a custom task. Basically, there's another type of object that the implementation object model allows us to build. And it's basically what's called a data flow component. Now, the data flow component basically can also be broken down into three types of data flow components. We could have the source, a destination, and a transformation component. I'm not going to go into the details of the implementation, but just to talk about some of the features of creating a data flow component. So these you use in the data flow tab, and they allow for communication with custom data sources. So if you need to load or save data to a data source that is not provided in the default sources, then this would be the right condition to build a custom data source component. The code follows most of the custom task features, like design time and runtime interfaces and so on. And we're going to look into a demo that Jesus prepared to show how to code a simple data flow component. And let's just go right into it, since we're running a little bit out of time.
Okay. So what we're going to be showing here is an actual dataset destination component. As Danny was explaining, in the data flow, there are pretty much three types of destination pipeline components. There are sources that contains no inputs and a set of outputs. There are transformations that contains inputs and outputs, and there are destinations that contains inputs but not outputs. Also, there are synchronous transformations that basically receive a number of rows and output the same number of rows. So basically there is one output per input, and there is asynchronous transformation when the number of output doesn't match exactly the number of inputs, or the transformation needs to receive all the inputs before it can actually output anything. So you can think in a data flow as a direct graph where the nodes are sources, transformations, and destinations. So when you create a custom pipeline component that has a call, you basically inherit from this class. It doesn't matter if you're implementing a source, a destination, or a transformation. And this base class is the one that implements the design time and also the runtime based behavior. So it behind the scenes, you don't need to be aware of that, but it is good to know. It implements two interfaces, the IDTS design component 90 and the IDTS runtime component 90, that contains the base implementation for my design time and runtime components. Then using this attribute is where you declare if your task is a source, is a destination, is a synchronous transformation, or is an asynchronous transformation. In the same way that the control flow custom task, you need to implement the validate, or you should implement the validate method. This custom task is a data set that actually receives a set of rows from a data source and outputs the XML representation of the data set. So for those of you that were wondering why XML SSIS contains an XML source and not an XML destination, using the dataset custom task, you can have an XML destination. So in my validate code, you should do your custom validation rules, and the output is a set of flags that are saying, okay, the configuration is okay, the configuration is corrupt, and also the configuration needs more metadata. I don't want to go in details into that, but when you build pipeline components, you can actually specify results that the user needs to modify. So if you say the task is corrupt, the user needs to change the value. Or if you say the task needs more metadata, the engine, the designer, is going to call another method that is called reinitialize metadata, where you can implement the fixes to your configuration and don't require any developer intervention at that time. So this is pretty much the design time behavior. There are much more to it. I mean, implementing custom pipeline components are way more complex than implementing control flow tasks. There are much method to implement and more performance considerations to take. The way that the engine passes the data between data flow tasks is using buffers. And buffers are a new concept in SSIS that determines a huge difference between the old DTS model and the new SSIS model. In the way that the SSIS engine works is the sources and the transformations output the data in buffers that you can control based on performance metrics, and the same buffers is being passed from one source to a transformation, from the transformation to the destination, and so on and so forth, until you reach an asynchronous transformation that in that case there are other algorithms that need to take place, like copy the buffer and other things that needs to happen. But what that allows you to do is to keep your performance under the limits of that buffer. If you can do heavy stress testing with SSIS with millions of rows, you will notice that the performance is pretty much the same down the road. And this is because the data between one task and the other is flowing using buffers. It's not copying the data every time that a new task is invoked. So at runtime, the engine is going to call the pre-execute method in which it will give you the column definition. So you can take that method and actually loop through your columns and create a collection, let's say an array list or a generic collection with your column names. So when the engine actually calls the process input method in the case of a destination, where it will give you the buffer, you already have a column list with the column names that you populate using the pre-execute. So in the process input method, the engine is going to give you a buffer of rows, and you need to loop through and do what you're going to do. In this case, it's populating a data set in memory, and after that, in the post-execute method, is going to save the XML to a file. So I want to real quick show this package that takes a contact list from a database and use the data set destination to create an XML representation of those contacts and output that representation to an XML file that is declared in the contacts.xml connection manager. So when once that I run the demo, you should see a contacts.xml file gets dumped in this location. Going to run this real quick. There is my contact list, 9 rows. There is the XML file. You can obviously, you will see the list of contacts that get populated from the data set. So summarizing, you have 3 main types of pipeline components that you can build. You can build sources, you can build destinations, and you can build transformations. In the case of transformation, you can choose to build synchronous transformation or asynchronous transformations. In any case, you need to inherit from the pipeline component class and then customize your behaviors depending of the actual component that you are implemented. So I'd like to go back to the presentation, and actually Dan is going to explain a real-world SSIS component that we create for Salesforce.com.
Right, and the AdapterWorks Salesforce.com data flow component. Basically, let me explain a little bit what Salesforce.com is. There is a web-based CRM company out there called Salesforce.com, and it exposes a web-based API that any company could use to upload accounts and contact names and so forth. And now there's a need for a way to interchange and extract information with this web-based API using web services. So there was a need now for taking information from SQL Server and exchanging it with Salesforce.com, and the data flow component is a perfect example of how can this be done using SSIS. The data flow component that AdapterWorks built basically consists of 2 of those components, a source component and a destination component. And it basically does, it pulls data from Salesforce.com using a specific language that Salesforce.com exposes, known as Salesforce Object Querying Language. And we're going to go into a demo right now to see how exactly that works. And Jesus.
Okay, here we are. In the last demo, we show how to build a custom destination. Now we're going to show a real-world custom source. So as I explained previously, sources has outputs, not input. In the case of the Salesforce.com source, is a custom source component that connects to Salesforce.com and execute Salesforce.com object query language query, like you can see here in this property. Actually get the representation, the data from that query, and populate a set of rows based on that result. So if I go to my column mappings column, you can see tab. You can see the set of rows that I'll be outputting to the next transformation. And the next transformation is going to do a conditional split based on the data that comes out of Salesforce.com. The first task is query my leads in Salesforce.com, and this transformation is checking for the status of the list. If the status is not contacted, it's going to go to one database. If it's another status, it's going to go to a different database. This is an example, if you wish, of how to build custom LOB line of business tasks for SSIS. I mean, SSIS is so rich in their object model that the expectation is that people start building tasks for things like SAP, PeopleSoft, Salesforce.com, JD Edwards, and actually build a complete set of LOB tasks around the SSIS ETL model. So I'm going to real quick log in my Salesforce.com that I should re-log in again, I guess. I'm on wireless, so if this demo runs a little slow, you can blame the internet company. So there is my leads list. I have around 500 or 400 leads here. And the custom task is going to take down and do a bucket load down to two database using SSIS. So I'm going to run this package real quick. This is actually the one that takes the longest time because the first time that you connect to Salesforce.com, it actually takes a while. So
plus you're on wireless, so that's a little bit slow.
There are my lead lists. There are my tasks here, my order. So as you can see here, I've received 400 rows from Salesforce.com. I output 409 to one database and 6 to the other database. And this is just an example of a real LOB application that task that we build using the SSIS custom task model that can help to merge, if you want, the rich ETL capabilities of SSIS with the functionality of your LOB application. So using this, you can have SSIS package that move data between your SAP and Salesforce.com, between your Oracle and Salesforce.com, SQL Server and Salesforce.com, so that kind of functionality. So I think that we have 5 minutes left. Going back to the presentation.
Right, and that was pretty good.
Yeah, thank you.
We're going to go about real quick about session summary, things we talk about, and basically what you have to a good takeaway would be to know about the extensible power that the SQL Server integration services offer you in implementing these connections and these connectivities. And you saw some demos using SQL Service Broker and Salesforce.com integration for that. You can always get more information on these topics either on books online or You can also visit the AdapterWorks site where we have a user forum.
Yeah, we are going to be posting the demos for this session in AdapterWorks, and Dan is the program manager for AdapterWorks, so he should take care of that.
Right, and if there is nothing else, I guess we can open it for some last-minute questions and answers. Let me go check the queue manager.
Great. Well, thanks a lot. And while we're getting our questions queued up, you can go ahead and submit your question in the lower right corner of your screen by typing in your question and then clicking on the Ask button. Now, before we get to our questions and answers, I'd like to go through just a quick couple of things. For upcoming and previously recorded live webcasts, you can go out and access hundreds of hours of great content at Microsoft.com/webcast. Now, if you have a webcast content idea, or if you'd like to let us know if there's a particular topic that you'd like to get covered, then you can contact us at the URL that we have listed here. I will actually copy this URL into our question and answers window here in just a few moments. Now, we want to let you know that today's webcast was presented using Microsoft Office Live Meeting. You too can get your own free 14-day trial by visiting Microsoft.com/present-live. At this point, I'm going to go ahead and launch our survey, and we'll go ahead and leave this survey up for the duration of today's call. But we'd like to have you go ahead and click on one of the links here listed in front of you, depending on how you register for today's webcast, and then provide a few quick minutes of time to give us your evaluation feedback. We really take your comments seriously, and we love hearing from you so that we can make even better webcasts in the future. So I really do appreciate your participation in that. So at this point, Danny, I'm going to hand it back over to you, and we'll go ahead and start our question and answer session.
Thank you, Ryan. Okay, real quick, I got a few questions here. I'm going to get the quick ones out of the way and get the other ones back to Jesus. They ask, how can I get a trial version of the Salesforce.com connector? There's a trial version available on the AdapterWorks website, so you can just go in, log in there, and you should be able to download it along with some data sheets that belong to it. And if you need any other help on doing that, you can go ahead and just send me an email. My email should be on the website. Another question is, where can I get more information about custom SSIS? Survey books online will be it's an excellent source of information. There's a lot of other user groups that you can do that. If not, you can always send me the questions, and I'll try to get the answers for you right away. Jesus, there's a question here: can SQL 2005 transfer data between servers for MSDN system tables?
So that's a complex one. If the question is related to if you using SSIS you can populate data in the system tables, you can, as long as you have the correct permissions. But you should be careful when you do that, because if you send some invalid data to a system table, that can actually I mean, the repercussions of that kind of actions, I mean, you don't know. If you delete some rows and add some rows, you can predict the behavior of your SQL server. So the system tables are very sensible. You should be sure of what data you're sending to it. If I can complement the first question that, or the second question, that where you can get more information about custom tasks, there is a great white paper out there that is called the Lessons from Project Real. Project Real was a project that the SSIS team worked to do real-world implementations using BI, UDM, and SSIS. And there are a couple of white papers about the SSIS lessons. One is just basic SSIS, well, not basic, but just the SSIS piece. And there is another white paper about the lessons that they learned building the custom tasks that they need to build to get Project Real working. So that's worth it reading. It's pretty deep. It's a real-world scenario, so you should learn a lot reading that white paper. I'm seeing another question that says, I have a package and I have set some variables. When I going to prove it, I don't know how to get the values of that the variables are getting. I'm assuming that this question is related either in a custom task or in a script component. So I'm going to real quick switch to my desktop to show you how to do that. This was the first demo that I did.
I'm sorry, Danny. We need to go ahead and stay on that survey slide if possible. Just we can allow that everyone has ample time to fill that out. So if you don't mind, I will need to put it back on.
Oh, okay.
I apologize.
Well, anyway, there are methods either in the script task or in the custom task that you create that allows you to access a variable. It will give you a variable connection that you need to log either for read or write. So you have to do variable list dot log for read or log for write, and then that will return another variable list that is the one that you use to access the variables. So that should be pretty straightforward. In the SDK samples, you can find some sample code about how to do that.
Okay, I don't see any more questions. Let me just stay here for a few more seconds.
Once again, ladies and gentlemen, if you'd like to send in a question, please enter your question in the lower right corner of your screen and then click on the Ask button to submit your question into our queue.
Okay, while we're waiting, well, I just want really to thank you all for attending, and if you need more information, feel free to contact us at tconnect.com or adaptworks.com. Thanks you again for attending.
Great, and at this point, ladies and gentlemen, we'd like to thank you for your attendance in today's webcast. We appreciate seeing you here and look forward to your attendance on our next webcast. Ladies and gentlemen, this will conclude the audio portion of today's call. You may now disconnect from this session. Thank you.